Assalamualaikum. For today task, I want you to do exercise 2.3. Draw the structure correspond to the following name. Okay, I want you to draw the structure of this compound. And exercise 2.3b, give the IUPAC name for the following compound. Later, draw the structure formula for this compound. All these questions we will discuss on Thursday. And also 2.3a. Okay, we continue with preparation of aldehyde. So aldehyde can be prepared from the primary alcohol. Okay, why we call as a primary alcohol? Because OH is attached to the this cyclohexyl methanol. Okay. And this OH is attached to this carbon. This carbon is primary carbon. When OH attached to primary carbon, we call as a primary alcohol. Okay, and then this compound react with PCC, pyridinium chlorochromate. Okay, this one will oxidize. PCC will oxidize this part to carbonyl group, which is aldehyde, and the name is cyclohexane carbaldehyde. And for the lithium aluminium triterbutoxide hydride is a milder reducing agent that reacts faster with acid chloride than with aldehyde. So lithium triterbutoxide hydride reduce the acid chloride Cl to hydrogen. So it will produce aldehyde. And for the preparation of ketone, okay, we have a secondary alcohol readily oxidized to ketone with sodium dichromate in sulfuric acid or by potassium permanganate. So here is secondary alcohol because this carbon is categorized as secondary carbon. Okay, this part will be oxidized by sodium dichromate to produce a ketone. And for the Friedel-Crafts acylation, okay, reaction between the acyl halide with a benzene ring in the presence of aluminium trichloride solvent H2O. What is the function of the aluminium trichloride is to boost the reaction, or we call as this a catalyst. Okay, please take a look of this example. Okay, we have this structure. Okay, this structure and we call as para-nitrobenzoyl chloride. Okay, so this part will be attached with a benzene ring to produce para-nitrobenzophenone. Okay. So here, why here G is hydrogen and activating group or a halogen group or a halogen. Okay, let's say here G is hydrogen or halogen group. So halogen group here, for example, Br, Let's say we put here Br. So Br is categorized as orthopara director. So it will direct this group to the location ortho and location para. Para is 4, ortho is 2. Location 2 and 4. And for the reaction of aldehyde, or we call as oxidation, so this part will be oxidized by using chromic acid to produce hexanoic acid. Or it can be oxidized by using silver oxide in the presence of tetrahydrofuran diluted. This will act as a solvent, and this is the condition which is in alkaline condition, sodium hydroxide. And after that, react with hydrochloric acid in the presence of water, so to produce carboxylic acid. And here you have aldehyde group oxidized by using oxygen to produce carboxylic acid. Aldehyde can be reduced to primary alcohol. Ketone can be reduced to secondary alcohol. Okay, here is aldehyde reduced to primary, ketone reduced to secondary. The double bond group will reduce to OH group. And for the catalytic reduction are generally carried from 25 degrees C to 100 degrees C at 1 to 5 atm hydrogen. So here, it will be reduced to OH. This is the condition. Platinum will act as a catalyst. The condition is in hydrogen. Platinum as catalyst, the condition is 25 degrees C at room temperature at pressure 2 atm. And if we have two functional groups exist in the structure, which are double bond and a carbonyl, so if you react with 2 mole of hydrogen in the presence of nickel as catalyst, so 1 mole hydrogen will reduce this part to produce OH. Another mole of hydrogen reduce this part, double bond will be single bond. And the most common laboratory reagent for the reduction of aldehyde and ketone are sodium borohydride, lithium aluminium hydride. Why? Because it has hydride ion, or we call as a very strong nucleophile. Metal hydride reducing agent do not normally reduce carbon-carbon double bond, and selective reduction of C double bond O or C double bond C is often possible. If you use sodium borohydride, it will selectively choose the functional group that it want to reduce. So sodium borohydride, it will choose C double bond O group only to reduce to alcohol. The double bond C double bond C, or we call as alkene, cannot be reduced by sodium borohydride. And for the sodium borohydride here, the reduction of sodium borohydride are the most commonly carried out in aqueous methanol, in pure methanol, or in ethanol. 1 mole of sodium borohydride reduce 4 mole of aldehyde or ketone. Later, Let's do this part. Draw the structure of the alcohol obtained when the following carbonyl compound are reduced. And for the addition of HCN, hydrogen cyanide, add to the C double bond O of an aldehyde or ketone to give cyanohydrin. Cyanohydrin is a molecule containing N, OH and C triple bond N group bonded to a same carbon. So this hydrogen will be substituted with Cn and double bond will be single bond. Here you just add H. And this is the reaction of aldehyde and ketone, or we call as Grignard reagent. This Grignard reagent, this bond, okay, here we'll attach to here, 2 electron goes here. Okay, so it will be CH3, CH2, CH2. Here is you connect between this CH2 and it will be Mg, Br complex, because this group already leave this group, this bond will break, so it will attach to oxygen. And when you have hydrogen here in the presence of water, so you will get primary alcohol here. So here is a phenyl Mg, so you will attach phenyl here. Then you will get here is secondary alcohol. Okay, draw the structural formula for the product formed by treating each compound with propyl magnesium bromide followed by aqueous hydrogen chloride. Okay, let's do this question in a class notebook later. And for the ammonia primary aliphatic amine and primary aromatic amine react with C double bond O or aldehyde and ketone to give imine, Schiff base. Imine, a compound containing a C double bond N, also called as a Schiff base. Okay, this one we call as aniline. So this hydrogen will be removed from the this oxygen will be removed. Sorry, this oxygen will be removed. Okay, so here H2 also will be removed. So H2 combined with O to produce H2O. While this double bond will attach to this nitrogen to form this structure. Okay, here, so you just connect NH and then this O you will eliminate from this structure, combine with here H2 to produce H2O. The carbonyl group of aldehyde and ketone react with hydrazine and its derivative in manner similar to its reaction with primary amine. Okay, here is hydrazine. So you eliminate this group H2O, you just connect double bond with N and H2. And this compound we call as a hydrazone. Here is the name of the reagent, hydroxyl amine, phenyl hydrazine, and then the name is here 1, 2, 3, 4, 2,4 dinitro phenyl hydrazine, and here the name is semi-carbazide. Okay, here when this aldehyde react with hydroxyl amine, okay, you will remove this group H2O and double bond will connect with between this N to produce an oxime. And how about here? So double bond here will attach to N dash NH2 to produce a hydrazone. And here double bond will attach to N NHC6H5, and you eliminate water to produce a phenylhydrazone. And this double bond attached here will eliminate H2O. This double bond attached with N and H, you get this structure. 2,4-dinitryl phenylhydrazole. And how about this example? This double bond attached with this N. N and H, C double bond O and H2, then you get a semi-carbazole. Okay, after that, please do the question, draw the structural formula for the product of the following acid catalyzed reaction. And for the reaction of aldehyde and ketone, we call as aldol reaction. So when the aldehyde react with aldehyde in the presence of sodium hydroxide, so this CH3, C double bond O, this one will change to OH. And this one will attach to CH2 and then C double bond OH. Or ketone react with ketone itself. So it will produce here the first group 1 of ketone, double bond O will change to OH. And it attached to this CH2 and C double bond O CH3. And reaction of aldehyde and ketone, aldol reaction. Aldol products are very easily dehydrated to an alpha beta unsaturated aldehyde of ketone. So when this product which contain OH and double bond O, when it react with warm in warm temperature, either or acid or base, and then this part will be changed to double bond. OH will be eliminated from the structure. And this aldol reaction are reversible, and often little aldol product is present at equilibrium. Equilibrium constant for dehydration are generally large. If the reaction condition bring about dehydration, good yields of product can be obtained. And for the Cannizzaro reaction, exception to the characteristic aldehyde and ketone reaction for carbonyl without alpha hydrogen. OH minus, or we call hydroxyl ion, add to the aldehyde here to give tetrahedral intermediate. So it will attach to produce OH, and here it will change to O minus. And at the same time, it will react again with another 1 mole of this benzaldehyde in the presence of acid. Okay, to produce at the end of the reaction, so yang ni you akan dapat double bond O. Here is OH, so you will produce carboxylic acid. And another one hydrogen combined here. These 2 electrons will give to here, rearrange, then you will get benzyl alcohol. So one product is carboxylic acid, another one product is alcohol. And then reaction of aldehyde and ketone, or we call as iodoform reaction. So it will react with an alkaline solution of iodine when heated to produce a yellow precipitate of iodoform CHI3. Please make sure the C double bond O group must attach to methyl. Okey, kalau C double bond O sini tak attach kepada methyl group, bukan akil. Methyl, dia mesti methyl, satu carbon je kat sini, CH3. Dia mesti attach to at least one CH3 group. Maksudnya attach to satu akil group, iaitu methyl. So, baru boleh produce yellow precipitate ataupun iodoform CHI3. Kalau sini ethyl, kalau sini pun ethyl, so you tak boleh react dengan this reaction. Dia tak akan dapat yellow precipitate. The solution remain unchanged. So, make sure C double bond O kamu tu at least kena attach to one methyl group. Okay, draw the structural formula for the product formed by treatment of butanal with the following reagent. Complete for today.